Hi, my name is Sam Graham. I am part of the SIE 55 low-cost air traffic control radar for rural areas. I'm going to be talking about the Matlab portion of the presentation, as Jeff and Josh and Alex should have talked about the other parts of our presentation. So I'll get right into it. So we actually found a Matlab model called the air traffic control scenario from the sensor fusion and tracking toolbox. That was actually just what we wanted. It uses essentially an airport surveillance radar. That the simulation uses it for radars at international airports, right? So we basically modified it so that it would work in the Class G airspace. These are the three scenarios from the actual situation of the Matlab scenario, but we modified it so that we could get planes within the 15 kilometers of the radar, and I'll later show in a live demo what we did with those aircraft. So stepping into the code a little bit, basically it had this monostatic radar sensor for the radar on the control tower, and the main parameters that we changed were detection probability, which defines the probability of detecting a target with a radar cross section, reference RCS right here at the reference range. These were the main parameters that we changed to this monostatic radar object. So I'm going to go ahead and show that right now. Go over to this screen and walk you guys through the code a little bit. As I said before, we changed a few things to get it working inside of the Class G airspace. Here are the three targets which we adjusted to be in that airspace, and one we actually left out because I want to show in the simulation how we detect the targets within the airspace, and we actually don't detect the one out of the airspace. So we actually have an inbound airliner, we have an outbound airliner, and then we have one flying. Oh, excuse me. We have one flying tangential to the airport, and so why don't I go ahead and get this running? Okay, so here's our radar. It's a mechanically steered monostatic radar, and so as you can see, it's in the center of our plot here, and the two targets. This is the incoming aircraft, and this is the outgoing aircraft, and you see that they're moving. And then we have this guy over here, which is the guy just outside of the detection zone. And so these little blue circles, as the radar passes, you'll notice those are detections. And so we can see that we're actually detecting those guys. And then on this pass here, we're actually creating tracks, as we have talked about in class. And so we'll create a track, and it has elevation information, speed information associated with those tracks. So essentially we pick up a couple detections with the radar, and we get characteristics like speed and heading, and as we'll see in a plot that follows when this simulation is done running, we'll see where the detections were and how we track the targets. Okay, so here it is. So this is kind of fun. This is part of the simulation. So essentially, you can use MATLAB to actually map it to coordinates. So as you guys can see, this is Massachusetts. Kind of fun. I didn't change any of that. Just didn't have time to put it in a rural area, but it's nice to know that we have a tool like MATLAB where we can put this in a different situation, maybe with mountains or whatnot, and get results that way. So this is a 3D plot of what we just saw. So let's see. So if I go in here, so this is our tower. This is our monostatic radar. Here's a target. Here's a target, and here's a target, right? And essentially, this is the guy that we didn't get any detections on, and the squares are our target tracks. And you can't see it very good on this one. I can kind of see it. So there's a little blue line right there because I didn't want to run the simulation for as long. We'd be here for 10 minutes. But essentially, when the simulation runs its full time, you see this little blue line here, and that's just basically the detections that we picked up associated with this track. So that's kind of fun. And then right here, let's see, let's hide that. So right here we get a table out, and so and actually show this. Actually, I'll show this in the presentation here. So our results were so it created a out of the 3 airplane scenario, we were able to get detections on 2 of the airplanes. The tracks were created and updated throughout the simulation, and as I said before, because of the reference range and the specified RCS of that 3rd plane, we didn't get detections on him. And if we would have had more time, we would have done a little bit more of a sensitivity analysis and shown plots. But yeah, I think there's actually a bug with something in the Matlab code that I was actually emailing the MathWorks guys about. But anyway, here this table, we have a track ID. We just say, hey, target T1, aircraft 1 was T1 and aircraft 2 was target 2. This was their true height, and this is the height that we estimated it at. This was the direction that they were heading, estimated and true, and see we're a little bit off in our heading there. And then the speed, we put a true speed of 150 meters per second, and then the speed was a little bit slower. So yeah, that's my portion of the slide. Though this was the 3-dimensional view that I just showed you guys, and I think Jeff will finish it up for you guys. So that's this portion of the project. Thanks for your time.